Has anyone noticed that software today is getting bigger and bigger? A few decades ago, a program might have been only a few hundred kilobytes. But today, even a Hello World application can be over 100 megabytes. For example, if you write Hello World in C, a few kilobytes are enough. But if you use Electron or package a GUI version with Python, congratulations, your Hello World can exceed 100 megabytes. Why is that? Are modern programmers just piling up garbage? Or have modern computers truly become more complex? Today, let's uncover the truth. First, let's travel back to the 1990s. At that time, software installation packages were small. For example, the full set of installation disks for Windows 95 was only 13 megabytes. Now, just the installation package for Chrome exceeds 150 megabytes. It's not because programmers have become lazy, but because today's ecosystem has become more complex. 30 years ago, writing a program meant building the wheel from scratch. If you wanted to print text, you had to write code to call system interfaces yourself. If you wanted a graphical interface, you had to draw the buttons and dialog boxes yourself. But now, it's different. Development tools come with ready-made library files and frameworks. For example, if you want to make a program with a GUI, you can directly use UI libraries like Qt or MFC, which already include ready-made buttons and menus. These libraries have to be compatible with different systems, devices, and versions, and also guarantee security and performance. So just launching a modern application is like summoning an entire army. For example, you write one simple line of code in Node.js, then execute npm install express. A few seconds later, your project folder might have grown by hundreds of megabytes of dependencies. Why? Because Express depends on other libraries, and those libraries depend on even more libraries, eventually forming a dependency hell. These libraries do improve development efficiency, but at the same time, they make every program bloated. According to statistics, about 60% of a modern program size comes from these must-have dependencies, because they not only include code, but also tests, configuration, documentation, and compatibility layers. Even if you only use one function, you still have to package the entire library along with it. And many modern applications need to run across platforms. That phrase sounds beautiful, but it comes at a huge cost. Take the Electron framework, for example. Its advantage is develop once, and it can run on Windows, macOS, and Linux. But Electron carries a simplified Chrome browser engine with it. No matter what operating system you're on, the program runs through that engine. That engine alone is about 40 megabytes. And together with your program code, there's your 50 megabytes. In other words, your application actually embeds a miniature operating system, and to stay compatible with older devices, programs also include compatibility code. For example, code supporting Windows 7. Even though 90% of users are already on Windows 11, that part of the code still has to be kept. Otherwise, older users will complain that the software doesn't work. Developers gain convenience, but users bear the cost in file size. Cross-platform frameworks solve compatibility problems, but make software more and more bloated. Next comes user experience. Modern users are no longer satisfied with black and white command line interfaces. They demand things to look beautiful and smooth. Buttons need hover animations. Window resizing must be fluid. Text should support high DPI anti-aliasing. And even features like dark mode and dynamic wallpaper linkage are expected. Thus, a large number of UI frameworks, rendering engines, and vector graphic libraries are introduced. For example, a simple rounded button might call dozens of rendering functions behind the scenes, involving GPU acceleration, memory caching, and layer composition. Add high-resolution icons, multilingual packages, localized fonts, and animation resources. What seems like just a single button is actually supported by hundreds or thousands of files behind it. Then there's security. 30 years ago, when the internet wasn't widespread, programs didn't have to worry about hacker attacks or data leaks. But now, software must guard against viruses, tampering, and privacy breaches. This requires sandbox mechanisms and security modules. A sandbox is like putting a protective shell around a program, so it can only run within a designated range, and cannot freely access other files on your computer. This isolation system itself can take up around 10 megabytes. For example, browsers. When you open a web page, you're actually launching a separate process. Chrome assigns each tab its own independent memory space to prevent websites from stealing data from one another. In addition, programs also include encryption modules and security verification code. For example, every time the program starts, it checks whether its files have been tampered with and encrypts data during transmission. Together, these modules can add another 10 megabytes. It's fair to say that within the size of today's programs lies a hidden security suit. This design is very secure, but also very resource hungry. The result is your computer has 8 gigabytes of memory, and Chrome alone can eat up 5 gigabytes. In the era of servers and cloud computing, this kind of bloat has been magnified even more. In the past, deploying a program required only a single executable file. Now, many applications run in the cloud. To ensure they can run on any server, developers use Docker to package programs together with the system environment they need into a container image. For example, a simple backend program might have only 5 megabytes of core code. But when it's packaged with the Linux environment and the Python runtime, the image size can instantly jump to 50 megabytes. And different programs might repeatedly package the same system environments, causing duplicate size. This is also one of the main reasons why cloud era programs become fat. Add to that virtual machines, containers, dependency libraries, and logging systems. Modern cloud software is like an onion. Each layer protects, abstracts, and isolates, but each also adds weight. This is a kind of balance, trading complexity for convenience. From a technical perspective, why do these layers cause size inflation? Take Linux's ELF files as an example. 30 years ago, ELF files had only code sections and data sections, a simple structure. But modern ELF files include symbol tables, dynamic linking tables, and debug information. The symbol table records function and variable names to aid debugging. The dynamic linking table records the positions of dependent library files. And debugging information helps programmers locate bugs. These additional sections make programs easier to maintain and debug, but also increase their size. Meanwhile, when the operating system loads a program, it needs to parse dynamic libraries, initialize the runtime environment, and create a virtual memory space for the program. Every framework comes with its own runtime. For example, Java needs the JVM, .NET needs the CLR, Node.js needs V8. Electron even embeds the entire Chromium. These runtimes make programs more general, secure, and portable, but also cause redundant overhead. Your computer might be running 10 different applications, each with its own V8 engine, each taking up hundreds of megabytes of memory. Therefore, larger programs don't necessarily mean worse programs. It's a result of software evolution. In pursuing speed, cross-platform capability, security, and user experience, we've sacrificed space and efficiency. But don't worry, lightweight technologies are already emerging, for example using Rust or Go for development. Programs compiled in these languages are native binary files, without interpreters or massive frameworks. A Hello World program can be just a few hundred kilobytes, or technologies like WebAssembly, which compile programs into lightweight bytecode that runs in browsers, reducing size by up to 90% compared with Electron. There's also native compilation optimization. Compilers can strip unused code and compress resource files, helping programs slim down. This era of bloated software might just be a transitional phase, when technology returns to its essence, making machines serve humans, not frameworks. Software may once again become lightweight. That's all for this episode. If you want to learn more about computer science, don't forget to subscribe to my channel. See you next time.